Greetings everyone. My name is Chenwi NebaCyril. I am a pricing analyst and manager at Walmart Incorporated, and I'm also a research scholar affiliated to Austin Peay State University. I am grateful and wish to thank the management of Science Father and Research Data Analysis Excellence Award for giving me this opportunity to present my project. Today, I will be presenting my research on Walmart sales predictions, which focuses on two main studies: a comprehensive study of Walmart sales predictions using time series analysis, and advancing retail predictions by integrating diverse machine learning models for accurate Walmart sales predictions. Let's dive in. For this presentation, we will start with the introduction and literature review. Then we will move on to the objective of this research, after which we will proceed to the methodology and overview, where we will talk about data collection and preparation, time series analysis, and machine learning models. We will then do a comparative analysis of the performances of the time series and machine learning models. Finally, we will discuss our results and draw conclusions, and then we throw light on the future works. Sales forecasting is a critical activity of businesses, enabling them to make informed decisions about inventory management, budgeting, marketing strategies, and overall planning. Accurate sales forecasting can improve operational efficiency and strategic planning, thereby enhancing a company's competitive edge. The literature review examines the various methods and models used in sales forecasting, their applications, and their effectiveness. Different studies have presented different methods of sales forecasting over the years, which include traditional, advanced, and machine learning models. Traditional methods of sales forecasting have different methods, some of which are qualitative methods that rely on expert judgment and opinion rather than quantitative data. Common techniques include the Delphi method, market research, and panel consensus. These methods are useful when historical data is not available or when launching a new product. The Delphi method is a structured communication technique which relies on a panel of experts. Studies such as Rui and Wright in 1999 highlight its effectiveness in achieving convergence of opinion on complex issues. Market research involves gathering data through surveys, interviews, and focus groups. Hawks and Bowie in 2005 discussed how qualitative research provides in-depth insights that can be crucial for sales forecasting. Quantitative methods, on the other hand, utilize historical sales data to predict future sales. Key techniques include time series analysis, causal methods, and statistical regression. Time series analysis involves techniques such as moving averages, exponential smoothing, and ARIMA. Box and Jenkins in 1970 provides a comprehensive methodology of time series analysis and forecasting. Causal models establish cause and effect relationships between sales and other variables such as price, advertising, and economic indicators. Green in 2003 discusses the application of multiple regression analysis in forecasting. Advanced statistical methods and machine learning models include regression models, which we can talk about the ridge regression, the lasso regression, and the elastic net regression. The ridge and lasso regressions are regularization techniques that prevent overfitting by penalizing large coefficients. Elastic net regression combines the penalties of ridge and lasso to improve prediction accuracy, especially with correlated predictors. With the advent of big data, machine learning models have gained popularity in sales forecasting, and some machine learning methods include random forest, support vector machines, neural networks, and deep learning. As for the industrial applications, in retail, sales forecasting is critical for inventory management, pricing strategies, and promotional planning. In finance, forecasting sales revenue is essential for financial planning and investment analysis. In public health, predicting sales of pharmaceuticals and medical supplies can help in managing public health crises. So despite advances in forecasting methods, challenges still remain, some of which include the accuracy of forecasts, which depends on the quality and granularity of the data. Incomplete or noisy data can lead to inaccurate predictions. Choosing the right model for a specific context is challenging too. And then integrating advanced models into existing business processes requires significant investment and technological training. Those are some of the challenges we face in retail forecasting. Time series analysis is a powerful tool that allows us to examine historical data and identify patterns and trends that can inform our decision making. By applying machine learning algorithms to this data, we can make even more accurate predictions about future sales and adjust our strategies accordingly. This can help us optimize inventory management, pricing, and marketing efforts to maximize sales and profitability. One of the key benefits of using time series analysis and machine learning for sales predictions is that it allows us to take a proactive approach to managing our businesses. Rather than simply reacting to past sales data, we can use these tools to anticipate future trends and make informed decisions about how to position our products and services for success. This can help us stay ahead of competition and better meet the evolving needs of our customers. Walmart has access to vast amount of data from various sources, including point of sale transactions, online sales, and customer feedback. By leveraging this data, we can train machine learning models to identify patterns and trends that can inform their sales predictions. For example, we can use time series analysis to examine historical sales data and identify seasonal patterns such as increased demand for certain products during holiday seasons or changes in consumer behavior during different times of the year. In addition to seasonal patterns, we can also use time series analysis to identify trends in customer behavior and preferences. For instance, we may notice that sales of a particular product are increasing over time, indicating a growing demand for that item. By using machine learning algorithms to analyze this data, we can identify the factors driving the demand and adjust our inventory and marketing strategies accordingly. Another benefit of using time series analysis and machine learning for sales predictions is that it allows us to account for external factors that may impact sales. For example, we can use data from weather patterns, economic indicators, and other sources to identify how these factors may affect sales and adjust our strategies accordingly. This can help us mitigate the impact of external factors and maintain a more stable sales performance. Companies are dedicated to utilizing data and analytics to drive businesses' success. Time series analysis and machine learning are just a few of the tools companies use to achieve this goal. By leveraging these tools, companies can make more accurate sales predictions, optimize their operations, and better serve their customers. So whether you are a customer looking for latest deals or businesses or looking to partner with companies are always working to provide the best possible experience for you. The objective of my research is therefore to enhance sales forecasting accuracy, which is crucial for Walmart and retail industries as a whole. Accurate forecasts help optimize operations, manage inventory efficiently, and meet customer demands effectively. This research explores two main approaches: time series analysis and machine learning models. We will explore both methodologies to understand their efficiency and efficacy in improving sales predictions. Retail sales forecasting is crucial for business success but comes with many challenges. The main issues include the quality and availability of data, which can often be inaccurate or incomplete. Seasonal changes and shifting trends make it hard to predict future sales, and promotions can disrupt normal sales patterns. External factors like the economy and competitors also impact forecasts. Technological changes involve combining different data sources and using advanced analytics, which need a lot of investment and expertise. Managing inventory to avoid running out of stock or having too much is another critical issue. Consumer behavior changes quickly. influenced by new preferences and shopping methods, requiring constant updates to forecasting models. Choosing and maintaining the right forecasting model ensure it doesn't overfit or underfit, and regularly updating it is an essential but difficult task. Overcoming these challenges needs strong forecasting systems, high quality data, advanced analytics, and continuous improvement of models. For Walmart, accurate forecasting is key to optimizing operations, managing inventory, and keeping customers happy. By tackling these challenges, Walmart can better predict sales and plan effectively. To tackle the challenges in sales forecasting, we employ two sets of methodologies: time series analysis and machine learning models. The time series models include ARIMA, SARIMA, Prophet, exponential smoothing, and Gaussian processes. On the other hand, the machine learning models consist of linear regression, multiple linear regression, generalized linear model, random forest, gradient boosting machine, extreme gradient boosting machine, light gradient boosting machine, artificial neural network, and support vector machines. Each of these models has unique strengths which we leveraged to improve prediction accuracy. The data used in this research comes from publicly available Walmart sales data. To ensure that the data was ready for analysis, we underwent several processes and steps. This included handling missing values, conducting feature engineering to create meaningful variables, and splitting the data into training and testing sets to validate our model's performance accurately. Let's delve into the time series models we used. ARIMA stands for Autoregressive Integrated Moving Average, which is excellent for capturing linear trends in time series data. SARIMA or Seasonal ARIMA extends ARIMA by including seasonal components. Prophet, developed by Facebook, is particularly effective for handling seasonal effects and missing data. Exponential smoothing helps identify trends by smoothing out data fluctuations, and Gaussian processes are non-parametric models that provide flexibility in modeling complex patterns. We evaluated these models using performance metrics like mean absolute error, mean squared error, and root mean squared error. Now, moving on to the machine learning models, linear regression, multiple linear regression, and generalized linear models are all regression models that we employed. Linear regression models the relationship between dependent variables and one independent variable. Multiple linear regression extends this to multiple independent variables. Generalized linear model further generalizes linear regressions to accommodate non-normal distributions of the dependent variable through link functions. Random forest is an ensemble learning method that constructs multiple decision trees and merges them for a more accurate prediction. Gradient boosting machines are sequential ensemble techniques that build models in stages to correct errors made by previous models. XGBoost, which stands for Extreme Gradient Boosting, is an optimized implementation of the gradient boosting framework. Light GBM, or light gradient boosting machine, is another gradient boosting framework that uses tree-based learning algorithms designed to be efficient and scalable. These models were evaluated using performance metrics such as mean absolute error and root mean squared errors. Now we move to comparative analysis of the different models employed in this research. In this section, we compare the performance of time series models against machine learning models. This comparison helps us understand which models are more effective and accurate under different conditions. When we look at the accuracy of different time series models, we use metrics like root mean squared error and mean absolute error. Root mean squared error measures the average magnitude of the errors, giving higher weight to larger errors, while mean absolute error provides the average of the absolute errors. Among the time series models, Gaussian processes stands out with significantly lower root mean squared error and mean absolute error, indicating a higher accuracy compared to other models like ARIMA, SARIMA, Prophet, and exponential smoothing. Now, let's examine the performance of the various machine learning models. Here, we also consider R squared, which explains the proportion of variance in the dependent variable predictable from the independent variables. Models like XGBoost and Light GBM or Light XGBoost show exceptional accuracy with extremely low root mean squared error and mean absolute error values, and near perfect R squared scores, outperforming traditional models such as linear regression, multiple linear regression, and GLM. This highlights the effectiveness of advanced machine learning techniques in capturing complex patterns in sales. Comparing the performance metrics, we observe that Gaussian processes in the time series model have the lowest root mean square error and mean absolute error, making them the best amongst the time series options. However, when we look at the machine learning models, XGBoost and light gradient boosting outperform all other models, including Gaussian processes, with their remarkably low root mean squared error and mean absolute error values and near perfect R squared scores. This suggests that advanced machine learning models are more adept at handling intricacies of sales data. Now let's discuss the strengths and the weaknesses of both approaches. Time series models excel in situations with clear linear trends and seasonal patterns, offering straightforward and interpretable forecasts. However, they fall short of handling complex nonlinear relationships in data. On the other hand, machine learning models like XGBoost and light gradient boosting are adept at capturing these intricate patterns, providing higher accuracy and predictive power. They do require more computational resources and careful tuning, but are invaluable for making informed operational decisions in scenarios with complex data dynamics. In summary, although Gaussian processes outperform other time series models, they still fall short of the accuracy achieved by machine learning models such as XGBoost and light gradient boosting machine. This finding suggests that for Walmart, a hybrid approach to sales forecasting could be most effective. By integrating time series models, which are adept at capturing seasonal patterns and trends, with advanced machine learning models that excel at identifying complex nonlinear relationships in the data, Walmart can achieve more accurate and reliable sales forecasts. This hybrid strategy could optimize inventory management by ensuring that stock levels are aligned with predicted demand, thereby reducing the likelihood of stockouts and overstock situations. Additionally, more precise sales forecasting can enhance customer satisfaction by ensuring that popular products are consistently available, that promotional activities are better timed and targeted. Overall, combining the strengths of both time series and machine learning models can provide a comprehensive and robust forecasting framework, leading to improved operational efficiency and a competitive edge in the retail market. Looking forward, future research can focus on integrating additional data sources like economic indicators and social media trends to enhance forecasting accuracy. Real-time forecasting capabilities can be explored to provide timely insights. Continuous improvements and adaptations of our models will also be crucial. Beyond Walmart, these methodologies can be extended to other retailers and even applied to different sectors such as finance and healthcare, demonstrating their broad capability or ability and potential to drive significant improvements across various domains. Sales forecasting is therefore a dynamic field that has evolved from traditional qualitative methods to sophisticated machine learning models. Each method has its strengths and weaknesses, and the choice of model depends on the specific context and data available. Ongoing research continues to explore new techniques and their applications, aiming to enhance the accuracy and reliability of sales forecasting. Here is a list of some references that can be of help or importance when carrying out retail sales forecasting. Retail sales forecasting is therefore a vital yet challenging task that requires navigating complexities such as seasonal variations, promotional impacts, and supply chain disruptions. By leveraging a combination of time series models for capturing seasonal trends and advanced machine learning models for identifying intricate non-linear patterns, businesses like Walmart can enhance the accuracy of their forecasts. This dual approach not only optimizes inventory management but also improves customer satisfaction by ensuring better product availability and more effective promotional strategies. Ultimately, a robust and sophisticated forecasting system is essential for maintaining a competitive edge in the dynamic retail industry. Thank you so very much for listening, and I really appreciate your time and attention.